This video will cover the topic of quadratic inequalities. First, let's review the terms for quadratic function, quadratic equation, and quadratic inequality. Recall that the quadratic function is represented by the function f of x is equal to ax squared plus bx plus c. This is also known as the standard quadratic form. The graph of a quadratic function is that of a parabola. We can also evaluate the function at particular x values. For example, we can find f of 2 by letting x equal to 2 and substituting it into the quadratic function, so that f of 2 is equal to a, and in parentheses 2 squared, plus b, and in parentheses 2, plus c, which would give us some y value, and the point would be parentheses 2 comma some y value. This point will be on the parabola, which is the graph of the function. We will denote the quadratic equation to be in the form of ax squared plus bx plus c is equal to 0. In this situation, we will be asked to solve for x values in which the function will yield a y value of 0. In other words, we will be looking for a point or points on the graph for which the y value is 0. These are the x-intercepts of the graph, and in turn, the x values of the x-intercepts are the zeros of the function. Therefore, our solution set will be the numbers in curly brackets separated by a comma. A quadratic inequality will be comparing the quadratic function to 0. This comparison can state the function to be greater than, less than, or greater than or equal to, or less than or equal to, meaning that we are looking for what parts of the graph that are greater than, or less than, or greater than or equal to, or less than or equal to 0. Another way to see this graphically is to ask, for what x values is the graph of the quadratic function at, or above, or below the x-axis, depending on the inequality symbol. The solution for quadratic inequalities will be the intervals of x values.